Okay, 2.3a, we're just going to investigate properties of the root x and the 1 over x functions. So to start, we're going to just sub in numbers from like 0, 1, 4, 9 into like the root x function. So root of 0 is 0, root of 1 is 1, root of 4 is 2, and root of 9 is 3. So when we go ahead and graph this, 0, 0, 1, 1, 4, 2, and then 9, 3, we get a graph that looks like this. Okay, so this is f at x equals root x. Okay, so simply if we had like the reflection piece, okay, which would be like negative root x, the reflection in the x-axis, let's call it g to x, then what would we actually have? We would have a parabola but on its side. Okay, so when we talk about the root x function, we only talk about like the one branch of what would be the quadratic on its side. Okay, so when we state the domain and range, we really want to focus on where this, what would be equivalent to the vertex of the parabola is. Okay, so kind of like the starting point. So we can set up the domain and range. X is an element of the real number system. Okay, now x starts at 0, and all of these numbers here, all the numbers go up. So x is greater than or equal to 0. Okay, and then the y values start at 0, and then the y's go up as well. So y is greater than or equal to 0. We're going to do the same thing, but for like the 1 over x function. Okay, so this is called a rational function. Rational is like a fraction. Okay, so when we sub in -1, we get -1, and when we sub in 1, we get 1. And these are the only 2 points that we actually really need to focus on. And the reason is because the 1 over x function has both a vertical and a horizontal asymptote. Okay, a vertical asymptote occurs at x equals 0. So that looks like this. And we have to label the vertical asymptote, okay, x equals 0. And we know that because this denominator, we talked about restrictions, okay, 1 over 0 is not defined. Okay, we also have a horizontal asymptote, and that occurs at y equals 0. And algebraically, it's because if you sub in 0 and cross multiply the x, well, 0 does not equal 1. Like 0x does not equal 1. It can never. So we have an issue there too. So horizontal asymptote at y equals 0. Okay, so these 2 points are important because one's going to be plotted in like one of the quadrants and the other and one in the other quadrants, and these should be kitty corner to each other, okay, like across diagonally. Okay, if we were to ever have a rational function and we get points in, for example, this quadrant and this quadrant, then that's fine as well. There's probably just a reflection. But these 2 points are just to show us where the actual rational function lies. Okay, so when we state domain and range of a rational function, I'll set it up, XER, such that, okay, it's going to be, x is going to hit every single number. So if we see these arrows here and here, we're going to go to infinity and negative infinity. So x is going to hit every number except for the vertical asymptote, which is 0. Okay, so x does not equal the vertical asymptote. If you want a little note for yourself. Okay, and then the y is going to be the same thing. Y does not equal 0. Okay, so the y's, these values are going to go up to infinity and down to negative infinity, but the y's are not going to equal the horizontal asymptote.